Hi everybody, this is lesson 10. It's about tuples and sets. I'm going to just show you quickly how tuples and sets work. I'm going to move to my IDE. First of all, just again recap what is the difference between a tuple and a list. A tuple has got, you'll see normal brackets, and a list has got square brackets, and then you've got a set that's got curly brackets. So if you want to understand the difference between all three, it's explained in the lesson around the different arrays that you do get, and you can just listen to that one. I want to just quickly show you the difference between what you can do with a tuple. So first of all, you can only do limited things with a tuple. So the first method that you can follow is the count method. Now, if you run it, you will see that if you leave it empty, there's nothing in there, so you need to put a value in. So if I say, how many times does the number 5 comes, or can you find the number 5 in the tuple? Now I'm going to add a few 5s there, just for demonstration purposes. There's 4 5s in there, and if I run it now, it should tell me that there's 4 5s in the list. So that's the one function that you can do. That Python doesn't allow you to add any items to a tuple or delete any items. You can only do count, and the other thing that you can do is you can index. And let's say I want to index 5. Then let's see what the return is. It tells me that at number 4, position 4, number 5 would be there. So let's see, 0, 1, 2, 3, 4. So at position 4 is the first occurrence of that item. So that is the only functions that a tuple can do. That's about it. You can't do any more with a tuple than that. And the tuple has got very limited value, so you normally use it when you want to make the list immutable, that nobody can change it programmatically. The second one that one can do is a set. Now you would see that the set is indicated by curlies or curly brackets, and the key thing about sets, you've got similar functions than with lists that you can access. And I want to first start with a list. Is I've got 2 sets. I then can do various things. So how do I access the functions within the set? First of all, I can either do it by, and I'm going to access the functions within set 1. I'm going to do it in 2 ways. I'm going to go first print, and I'm going to go set 1, and I'm going to say I want to access item number 2 and see if that works. It gives me an error because you need to access them very specifically. So that the same as with a list, that doesn't work. So I need to do something very special with it. So for, and I want to access all the items in the list. For x, which is my counter, it's any variable. You can use any variable you want there, it just serves as your counter. So, and I'm going to say set 1. And then I'm going to go and say print x. And watch what will happen now. Gives me all the individual items in a loop. That's the one way of accessing it. The second way of accessing it is to say, I'm just going to delete that part. If I want to find something in the set, I'm going to go 5 in set 2. And what's it going to do? It tells me that 5 is in set 2. True. It returns the value of true. So if I say 5 is in set 2, it returns the value of 2. that's another way of accessing it. The second thing is I can add an item to a set. If I want to go, and I'm going to go with printing the set. First of all, can I just print the whole set? See, I can print the whole set. Now I'm going to add an item. So I'm going to go set1 dot add, and I'm going to add the number 6. And let's see if it's going to do that. I must just remember to print set1. So let's do that again. And there you go. I've added number 6. Now what I want to do is remove items. So I want to remove 5. And I'm going to add 5, 6, 7. Let's and maybe again another 6 just for illustration purposes, so you can see there's a duplicate there, and I'm gonna run it. And you can see it's removed both 6s, so it will remove item 6 at both places, not only at one place. So that removes all items that's named in a certain way. The next thing is to join two sets. And this is a little bit of fun. So now what I want to do is to go and say, let's join two sets. So I have two methods in doing this. I can use the union method, or I can, and I'm going to call this set free, and I say set1 union set2. Then it will join the two sets. Let me just print again set free. So what I have is that I take set free, which is my new variable. I'm going to take, and I'm just going to delete set1, that remove. I'm going to take this list and join it with that list. And let's see if it works. And you would see that because it does not allow duplicates, it's removed all the duplicates, and it hasn't added anything new. So if I now go and I add 8 there, and I do the union again, you would see it would automatically add that item. So you would have a unique set of items based on the list. So you don't have to go and sort them or anything like that. It would just take all the unique items and make a new list of items using union. Now it would be interesting if you then use the other function, which is update. So it also updates the one with the other, and there is no update done on set 2 because it inserts the items of set 2 into set 1. And at the moment, it found no items to update because it keeps. And what you can also do, you can actually keep the duplicates or take the duplicates out. So, so now both sets have got duplicates. It's going to only take the duplicates when I use intersection update. I'm going to go intersection update. This function allows for only the duplicates to be kept in set free. Now I just must make sure that my syntax is right. and effectively it's set 1, and then I would want set 3 to keep the duplicates. Now what it effectively want to do is I'm gonna do this. So I'm gonna print set 1. Let's print set 1, and you will see that it returns just the duplicates that are in both. If I do it, so if I use the intersection update command, it will return the just the duplicates in both. If I use the plain update command, yeah, set1 dot update set2, it would update with everything, not only the duplicates. But it would only leave the unique numbers. So you would see that there are a few, so like 6 is duplicated, but it would not, there would not be 2 6s, it would be 1 6. 1 2 3 4 is unique, so it would compare both lists and actually just replicate between the two lists. And that's effectively what it does. It's a replication. That updates the replication. The intersection update effectively would do more than, it would take the duplicates in both that it's identified and make the new list set 1 a duplicate update. Now there's some other functions also. I can clear. I must just delete that. I can clear a list or a set. Don't call it a list, and it's an empty set. Or I can go and copy a list. Now I'm gonna go set 3 equals or dot equals set 1 dot copy, and it would copy the list. So it copies the list from there, but notice again, it is not allowed to keep duplicates, so it will automatically, when you call it, eliminate all the duplicates. That's another important part. So it's a dictionary must always, or a set must always be unique. Now I want to just deal with identifying the differences between two lists. So set 3 is, I'm going to do look at the syntax. There is difference, and then I'm going to say set 1, the difference between that and set 2. So I would insert in there the difference, and it would actually, and I want to go print set 3, look what it will do. It will just keep the differences. Identify what is not in set. So 6 is not in set 2, and then 7 is not in set 2, and 4 is not in set 2. If I swing it around and I say in set 2, what is the difference between set 2 and set 1? You will get the opposite. You will get that only 8 in set 2 is not the same as anything in set 1. But it will not populate the set 1 differences to this, to this set 3. Okay, so that is an important thing. And then I can also have a look and put some logics in there. Now I can return whether two sets have have a intersection or not, or I can even see if one set is a subset of another. So let's try subset. So this is great for a database. So I'm going to go with whether set 2 is a subset of set 1. And it will tell you whether it is true or false. I must just get the naming conventions right. It is subset. There it is subset of set 1. And I just want to delete that part. Is a subset of set 1. I'm going to run it again. And there you go, it's false. But if I take the 8 out, it will return true. Because that is a subset of that. Now I can go and I can do the opposite as well. Is set 1 a superset of set 2? I'm going to run it again. And it's true. It is a superset of set 2 because it's a bigger set, but all of set 2 is contained in set 1. So that's another thing that you could do with, so you can do quite a lot. I can also do, and this is more interesting, is where I look for the symmetric difference between the two sets. So I'm going to go set 1, and I'm going to say symmetric difference, and it is going to give me a value, and it says 4, 6, and 7 are differences, symmetric differences, and that means so it returns a set that contains all items from both sets, except items that are present in both sets. So if that means that the differences between those, so if there are so 1, 2, 3, 5 are present in both, so it will exclude it from the list. And then effectively what you would have is that 4 is not on the list on both sides, 6 is not on the list, and 7 is not. It will throw away the last 6 because sets do not contain duplicates. It would automatically eliminate it. And that is how sets work. And that gives you the background on sets. Thanks for listening. I think this is one where you have to practice it and do it yourself to understand exactly the differences. Again, just maybe last recap is that if you want to access the functionality, you go set the set that you want, and you put a full stop there, and it will call all the functionality that you can call, which is all the M's and nothing with the underscores. So you would see that there the underscore start, it's not of that, it's up to update, which you could then access and get the information from. And that is then how you deal with sets. Thanks for listening. Tune in next for dictionaries, and goodbye.